This video from Arlen Card is about sound waves. The common model for sound waves, or what people visualize, is the up and down motion of waves on a pond. If you throw a rock into a pond, as it enters it pushes the water aside, which makes ripples on the surface. These ripples move outward from where the rock went in. Yes, sound waves behave this way. They move away from their source in all directions. But there's another way of visualizing sound waves. Look at this Newton's cradle toy. If you let one stele smack into one side, the far stele moves out with nearly the same energy. This happens because the force directed against one side of the stack of steles has nowhere to go but into the next stele, until the end stele, which has nothing to smack into, so it travels outward, then slows because of gravity, then slides back in and collides with the stack from the other side, and the force travels back through the stack, with none of the steles moving very much, until the first one we dropped into the stack that started this whole back and forth motion. Similarly, the molecules, tiny little bits of matter that make up the air around us, are as close together as they want to be. So when one of them gets pushed by a vibration in the air, it smacks into the one that's in its way, which smacks into the next one, and that chain reaction continues onward, away from the source of the vibration. These two models, the wave on the water model and the colliding molecules model, combine to give us our best understanding of sound waves. While the colliding molecules model is the most accurate, the waves on the water model is the most intuitive. Think of it this way: when the molecules are smashed together, they are like the top or crest of a wave on the surface of a pond. But as they spread apart after the impact, they are like the bottom of the wave or its trough. Crest or peak equals high energy, and the trough equals low energy. The peak means the air is briefly compressed, then the molecules spring apart to form the trough, where the air molecules are less dense than they want to be. This peak, then trough, then peak pattern races outward from the source of the vibration, such as a speaker or a guitar. When these peaks and troughs, these compressions and rarefactions of air, reach our ears, they cause our ears' hearing apparatus to vibrate just like the source of the vibration did. And that's how sound is transferred from its source to our ears. Now that you understand the nature of a sound wave better, you're ready to learn about the 8 properties of a sound wave. This instructional video is copyright Arlen Card Incorporated, all rights reserved.